Okay, so I'm going to go over the review for the unit test on this video since we didn't get a chance to finish it in class for some of my periods, and for some of my periods I was not present today. So follow along with me here so that way you can see how to solve all of these problems. I'm going to pull up my writing utensils here. All right, so we're going to talk about the rate of change. Rate of change is also known as your constant, also known as your unit rate. But on the unit test, I'm going to tell you right now, they do not give you these dots. If they don't give you dots, you make your own dot. So you want to find a corner of the graph paper like here, here, things like that to make your own dots, okay? Don't pick one that lands in the middle of a box because now you're dealing with decimals and fractions and that just makes it more difficult. Okay, so let's get started. I'm going to hit these two dots. Now you always read a graph going from left to right, just like you do in language arts, just how you read. So going left to right, which dot do I hit first? I hit the top dot. So I'm going to start here. To make rate of change a little easier, I'm going to show you a little trick. It's the stair-step trick. How many boxes over does it take for me to line up with this other dot? It took me 2 boxes to line that up. Now, how many graph boxes down does it take? It took me 4. But because I had to go down, it's actually a -4. So my rate of change is -4 over 2. Now, if we divide that, we get -2. And that's your rate of change. For your y-intercept, what you're looking for y-intercept is where it hits this line right here. So you just go straight down this line until you hit the blue line or whatever line is crossing through it. So it hit right there. What is that point? Well, here's 0, 1, 2, 3. Now we don't say the rate of the y-intercept is 3. Because there is no 3 truly on a graph. There's always 2 points. So, what was your x? My x was 0. So, it's 0, 3. And I'm going to give you a hint. Your y-intercept is always when you have a 0 for the x. So, if you're looking at a table or you're looking at an equation, if you have 0 x's, that is your y-intercept. Now, to throw together the whole equation, I've always told you it's y equals something x. Well, now there is a word for that something. So it's y equals, and I'm going to kind of write it small here, your rate of change, and I'll put it in little parentheses, x. So there's your something. It's your rate of change. And then it'll be plus or minus. I'm just going to put plus for right here. And then I'm going to put in parentheses your y-intercept. So whatever you got for your y-intercept, that number goes there. This is also known as your start. It's where your graph started as well, okay? So when I go to put together the whole equation, I'm going to say y equals my rate of change. Oh, that's this number right here. That's going to be -2. Go lock that, please. X plus 3. And that 3 is coming from right here. So I only needed to use those 2 numbers. Now, the reason it's plus 3 is because this 3 was a +3. All right, now let's look at the table. It tells you here that this table is linear. If something is linear, that means the pattern never broke. So linear is when the pattern doesn't break. It's consistent. If your pattern breaks, like let's say your pattern is 1, 2, 3, 4, 5. That's a pattern. That's linear. But if your pattern goes 1, 2, 10, 15, 5, 6, it's all over the place, that's not a linear relationship. So how can you tell? Well, you look at your x column. Go straight down your x column. What is the pattern going here? So I went -2 to 0, that's +2. 0 to 2, that's +2. 2 to 4, that's +2. So I'm pretty confident in saying my pattern here is +2. Now looking down the y column, 11 to 16 is plus 5. 16 to 21 is plus 5. 21 to 26, I think it's pretty okay to say it's plus 5. Now, in order to write an equation, I have to have these two things. I have to have a rate of change and a y-intercept. So, my rate of change is your y over your x. So, it's the y pattern over your x pattern. So, in this case, it's going to be 5 over 2. Now, this is a perfectly legal answer in math. You can leave it like this because we're talking about a ratio. We're not talking about a fraction, all right? But if you want and it makes you feel better, you can divide that and get 2.5. I will take either answer. So, there's the first part to our equation is your rate of change. Now, the second part to our equation is we need to have a y-intercept. Well, remember when I told you up here your y-intercept is when your x is 0. So you look down your x column. Do I have a 0? Yes, I do. Well, what number is that 0 paired up with? 16. So my y-intercept is 0, 16. There's the second part to this equation that you need. So now when we go to write the full equation, we have y equals, and I'm going to use the 5 over 2 just to show you that it's a perfectly legal answer, x plus 16. And the reason it's plus 16 is because that was a positive 16 in that table. So look at a table, find if you have a 0 in the x column, and boom, there's your y-intercept right there. All right, so I need to scroll this down to get the ones below here. All right, for these, we are solving for x, okay? So the 24 needs to move because I can't do anything with the x just yet. I'm going to subtract 24 here because what you have is a plus 24. You do the opposite, which means minus 24. What you do to one side, you do to the other. These cancel. You get 9x equals 81. 9 times what gives you 81? 9 does. And there's your answer, and you're done. Now, if you look at this one, you have x's on both sides of the equal sign, and you have normal numbers. So you're actually going to move two things, okay? So I'm going to subtract the 9. Of course, you can subtract the x's first. It doesn't matter which way you go. It's going to cancel that out. Now, I need to subtract the 15. Even though it's the smaller number, that's not why I'm picking it. If I subtract the 21x and move it over here, I have canceled everything on this side of the equal sign. I can't do that. It'll make the equation unbalanced. So since I already have one cancellation over here, I need to have a cancellation over here. So the opposite of adding 15x would be to take away 15x. So I'm going to do that to both sides. Now you can see I have a cancellation on both sides. So my equation is now balanced again. So we have 36 take away 9, which is 27. 21 take away 15 gives me 6x. All right, I'm going to divide by 6 because I can tell nothing times 6 gives me 27. So I put that in my calculator and I get 4.5. And that's your answer. All right, last one here. You'll notice you have set of parentheses. Anytime a number is slapped against a parenthesis, that means to multiply. It also means to distribute in this case because there's more than just one thing in that parenthesis. So you have to multiply both. It's 9 times x and 9 times 3. So I get 9x plus 27 equals 36. All right, I can't do anything with that 9 yet, so I'm going to get rid of that 27. I'm going to subtract 27 because I'm doing the opposite. And what you do to one side, you do to the other. And this becomes 9x equals 9. 9 times what gives you 9? It's 1. Now down here, notice it says, which of the following expressions are equivalent? On the unit test, it may not say are. It may say are not. So friends, you have to read the directions. What you're looking for is that which of these problems down here have the exact same expression at the end once you simplify everything out. So in order to do this, you have to solve these. So I have 12 times 2x gives me 24x. 12 times negative 2 gives me negative 24 plus 10. Now, since I only have one number with an x, he's a loner. So I can't do anything with him. I can't combine him with anything. So I just bring down the 24x. Now, I do have two numbers here that don't have an x. Okay, I can combine those. They are like terms. Negative 24 plus 10, I'm going to subtract, and I get negative 14. That's my answer. That's as far as that goes. So I'm going to put a little squiggly under that. That's my answer. All right, let's look at this one here. I have one number with an x and one number without an x. They're both loners. So in this case, I have nothing to combine. And when you can't combine or simplify, that's your answer. So my answer in this case is 12x minus 2. I'll put a little squiggly under that. That's my answer. All right, C. I have to distribute again. So I have 12 times 2 gives me 24. 12 times negative 2 gives me negative 24, and then bring down that x, plus 10. Again, if you see, the 24 is a loner because it's the only one that has an x, so it's going to come down, but make sure you take that negative with it. Any number in front of the number goes to that number. Now, I do have two numbers here that don't have an x. I can combine those. So that's 24 plus 10, which gives me plus 34. So far, look at your three answers. None of them are equivalent. So I keep going. Last one. All right, I see one number here has an x, only one, so it's a loner. It comes down. And then I have 12 and a 10 and a negative 12. So that's 10 minus 12, which gives me negative 2. And that's my answer. So by now, hopefully you see that you have two expressions that are identical. And that is B and D. They both came out to the same expression at the end when you simplified. So those two are equivalent. But again, check the unit test. It may not say are equivalent. All right. I'm going to keep scrolling down here. Go to the next problems. Again, on the unit test, if they do not give you dots, you have to make your own dots. You read the graph going left to right. So going left to right, I hit this dot first. So I have to find the rate of change, the y-intercept, and make that equation again. So just like we did on the very first problem. To find the rate of change, to do it a little simpler, let's do the stair step. So how many boxes over did I go to line up with the dot below? I went over one box. How many boxes down did I go to actually hit the dot? I went down, so that's negative, one box. So my rate of change is negative 1 over 1, which means it's just negative 1. Now for the y-intercept, remember that's this line here. I'm going to go straight down this line, keep going, until I reach the line that crosses through it. I reached it right there. What is that point? Well, here's 0, there's negative 1, negative 2, here's negative 3. So my y-intercept is 0, negative 3. Now I have enough to write my equation. So if you remember, your equation is going to be y equals your rate of change, x, plus your y-intercept, or your starting point, okay? So y equals rate of change, negative 1. But we don't write negative 1x, we just put negative x. All right, leave the 1 out of it. Now in this case, I'm going to have a minus 3 instead of a plus 3. Why? Because this down here is negative. So that makes that equation negative 3 at the end. All right, let's look at the next one. Going from left to right, I actually hit this dot first this time. You notice the line is increasing. Okay, this one was decreasing. This is increasing. So I'm actually going to go up. So how many boxes up do I go to where I am level with the other dot? I went up 3 boxes. How many boxes over did I go to actually hit the dot? I went over 2. So my rate of change is 3 over 2. All right, let's find that y-intercept. I'm going to go right down this y line. It's hit right there. What point is that? Well, there's 0, 1, and that's 2. So my y-intercept is 0, 2. And it's a positive 2 because it's up in the positive zone. So now I get to go write my equation. I have y equals rate of change, 3 over 2, x plus 2. And this time it's because the 2 is positive. Now, if you look at this next problem, you'll notice you have a flat line. That means no matter what you do to the x, you're always going to get this answer for y. So there is no rate of change because there's no change in the line. The line isn't changing. It's staying flat. So for this one, there's no rate of change. And your y-intercept, if you go down the y line, hits right there. Well, what number is that? It is 0, 1, 2, 3. So my y-intercept is 0, 3. But when I go to write my equation, because there's basically no x, because there's no rate of change, my equation's just y equals 3. All right, let's look at problem 6 here. Wants to know the rate of change and the y-intercept. Okay, well, hopefully by now you've seen where these guys are all located. This should be a piece of cake. This is my y-intercept. That's my rate of change. Now, if there's no number in front of the x, that means it's a 1. Remember, we just don't write the 1. So my ROC here, excuse me, is 1. And my y-intercept is not 4, it's 0, 4. You have to give it in coordinates. And that's it. That's your answer. Now, if you look at this one, that looks just like the one we've just finished doing where there is no ROC. So we're going to say no rate of change. And my y-intercept is 0, negative 2. All right, this last one here, this is my y-intercept. There's my rate of change. So rate of change is 2. And my y-intercept is not just 3, it is 0, 3. And that's it. That's how you answer those. All right, let's look at number 7. I'm going to move this down. 7 and 8. Rate of change, y-intercept, equation, all the same thing. So the first thing you want to do is find the pattern. This side is going up by plus 1. This side is going up by plus 2. So my rate of change is 2 over 1, or we can just say 2. My y-intercept, remember, look for that x. Do I have a 0? Yes, I do. It's right there. There's my y-intercept. So my y-intercept is 0, negative 1. So we go ahead and write the equation. I have y equals 2x minus 1. Let's look at the pattern here. Going down this pattern, we have plus 1. Going down this side, I have minus 1. So in this case, my rate of change is negative 1 over 1. Don't forget, rate of change is your y over your x. So it's the y pattern over the x pattern, okay? But we can just say that's negative 1. Do I have an x0, a 0x? Yes, I do. It's right there. Now make sure you pick the 0x, not the 0y. So my y-intercept is 0, 1. So let's write our equation. I have y equals negative 1x, but we don't say negative 1x. We'll just say negative x, and this is a positive 1, so we say plus 1. All right, this one here, let's look at the pattern. Going straight down, my pattern here is plus 1. Going straight down here, my pattern is plus 0. There's no change, If you have this happen where one side of the table is all the same answer, no matter what, That means you have no rate of change. You have no x basically, because no matter what you do to the x, you always get the same answer. So in this case, x doesn't even really exist. So when you go to write your equation, my y-intercept is right there. So y-intercept is going to be 0, 1.5. So when you go to write your equation, it's just y equals 1.5. Okay, last few problems here. We're just going to solve for x. I can't get rid of that x yet. I have to get rid of the 10. Now this 10 is over here. It's a positive 10. So what's the opposite of positive 10? Negative 10. So I'm going to subtract 10 from both sides. Those cancel and I get negative 5x equals 10. Negative 5 times what gives me a positive 10? That's going to be negative 2. Why is it negative 2? Because a negative and a negative equal a positive. All right, over here. I have to do the distributive property first, so I'm just going to drop this 2 down. All right, we have 3 times x, which is 3x. 3 times 1, which is 3, equals 6x. Now, before I can move on, I notice on one side of the equal sign, I have friends that are the same. I have numbers without x's. I need to combine those first. So I have 3x, and then 2 plus 3 gives me plus 5. And then I drop down my 6x. Now I can start moving things around. So the first thing I'm going to do is I'm going to move this 3x. Why the x? Because I have an x over here. I can't move the 5. He's a loner in this equation. So I'm going to do minus 3x because this is a positive 3x. Opposite is negative 3x. What you do to one side, you do to the other. The x's cancel and I get 5 equals 3x. If you divide that, you would get x equals 1.6. Repeat. All right, next one. Distribute first. Negative 2 times 2 gives me negative 4. Bring down that x with it. Negative 2 times negative 3 is going to be positive 6 equals negative 2. First thing you want to do is move that 6. Well, what's the opposite of adding 6? It's going to be subtracting 6. So I'm going to subtract 6 from both sides. These cancel. Bring down the negative 4x equals negative 2 plus, minus 6. Sorry, kind of got drifted off there. They're both negative, so I'm actually going to add, and I get negative 8. All right, negative 4 times what would give me a negative 8? X would have to be positive 2. All right, last one. I can move x's and I can move numbers on this one. I'm going to go ahead and move my x's first. I'm going to move the 4 because I like to keep x positive. So I'm going to say add 4x to both sides. Those cancel. I'll bring down my 15. 10x plus 4x is 14x, and bring down the plus 45. Now the next thing I can move is my 45. Now I know a lot of students will say, well, move the 15 because, you know, it's the smaller number. But if I move the 15, I have nothing left on this side of the equal sign. That is a major rule. You cannot break that rule. So, hey, in math, negatives exist. It's okay. So I'm going to move this 45. What's the opposite of adding 45? Subtracting 45. So I'm going to subtract 45 from both sides. The 45s cancel. 15 take away 45 is negative 30 equals 14x. All right, now I divide by 14. And when I divide by 14 on your calculator, you're going to get x equals 2.1428 and so on. So you could just round this to 2.1 and that would be a perfectly fine answer for me. All right, so make sure you have these notes. By the way, you get to use this as your one sheet of notes for the unit test tomorrow. Also know how to do the t-shirt like problems where you have a fee versus not a fee, like a membership fee costs this much and a non-membership fee costs this much. and points of intersection. So look in your composition book and make sure you have that. Period 7, just make sure you understand that a membership fee is going to be your starting point. So just to kind of show you guys, let me see if I can pull this up real quick. I'm going to erase this. So a membership, let's say a membership fee was $25 a month. If you're a non-member, it's 0, but you have to pay more. It'd be one of those situations. So this right here is going to be your y-intercept. That's going to be where it starts. Your rate of change is how much your item is, or how much it's going to be when you go. So let's say it's a golf membership. The golf membership charges you $20 for each time you come to play golf if you pay the $25 membership. So the 20 would go in front of the X and the 25 would be here as your fee. If you're not a member, it could be in a situation where you go to play golf and it's $50 to play golf, but there's no membership fee. You're just going to pay more. So know how to do those types of problems where when you go to graph them, the lines intersect at one point like that. And that just means that at that point, no matter what, if you're a member or not a member, you would pay the same amount. Okay? So if you have any questions about that, you can ask me on Thursday. I will help you then. All right. Bye.